On Friday we did sharing, where you had equal shares. Today is 2.2, where you have unequal shares. Page 46. Sometimes there are reasons to share quantities unequally. Suppose your older brother paid more than half the cost of a video game. You might think it is fair for him to spend more time playing that game. You might think at a party you might agree that your friend should take the bigger piece of chocolate cake because your friend likes chocolate more than you do. Two sisters, Crystal and Alexa, are going to a strange birthday party. Instead of birthday cake, pairs of party guests are each served a large gummy worm to share according to their ages. Since the sisters are not the same age, they do not share their fruit worm equally. Crystal is 12 years old and Alexa is 6 years old. Their gummy worm has 18 segments. According to their ages, Crystal gets 12 segments and Alexa gets 6 segments. The ratio of the girls' shares of the worm, 12 to 6, is equivalent to the ratio of their ages, 12 to 6. So according to the rule, how would the girls share a 9-segment gummy worm? Draw it on the back of your paper if you need to.
A 9-segment?
A 9-segment gummy worm. Now again, they said it's a 12 to 6 ratio. So about this, oh, I get that.
It looks like, what time is it? 8?
You can walk around and maybe look over on that table and maybe look over here. But I haven't seen it today. So just go and look around and see if you can see it. So I'm drawing. Those of you talking aren't drawing.
Oh, on the back?
Yes.
Can we do it?
You can. But just know whatever you do it on is turned in tomorrow, or tomorrow with Fridays, today's, and tomorrow's. It's all 3 of lesson 2, and you're turning it all in together at one time. So if they said that you had a 9-segment worm, and I've just drawn it in 9 segments, let's say that I reduce this down by 6. Let's do it by 6. How many times will 6 go into 12? 2. How many times will 6 go into 6?
1.
That means for every 2 that Crystal gets, Alexa gets 1. So for every 2 that Crystal gets, Alexa gets 1. For every 2 that Crystal gets, Alexa gets 1. For every 2 that Crystal gets, Alexa gets 1.
That means Alexa gets 6 and...
No, I mean,
so Crystal gets 2, 4, 6. Crystal gets 6. Alexa gets
3.
1, 2, 3. Could I have reduced 12, 6 to 6 thirds?
Yes.
If I had taken the original 12 to 6 and divided it by 2 instead of 6, it would have gone down to every 6 Crystal got, Alexa would have gotten 3. That's equivalent to 12 to 6 and 2 to 1. This is called the unit rate. Remember when that second number is 1? So if I was asked to take it down to the unit rate, you always try to get that second number to be to every 1 segment, she gets 2. Now again, 6 to 3, 2 to 1, 12 to 6, all those are equivalent ratios. And we've talked about equivalent ratios. We've talked about unit rate. But if I had to draw other segments for them, they would have to be multiples of 2 plus 1 is 3. That's why this one was 9. It was a multiple of 3. I could start with a 3 segment, a 6 segment, a 9 segment, a 12 segment. All of these could be divided at a 2 to 1 ratio without having to make any extra cuts. So, knowing that, and there is a launch video that goes with this, and the front board is glitching. You can't even watch it with the jumping that it's doing. So I will go ahead and I will attach it to the plan book, and if you want to watch it, if you go in and you have to watch the lesson again, then the launch video will be there for you. It's just a bigger dog that is like a 12-pound dog, and then a smaller dog that's like a 3-pound dog, and how they would be fed at a different ratio. They wouldn't get the same share because the bigger dog would need more. It's just another one of those examples when shares would be unequal but still in a proportional ratio. So we're fixing to start the problem. So we're on page 47. Page 47, and you're either answering on your own paper or the back of the recording sheet. Know that the tape diagrams on the front of the sheet are there for you if you need them. Yes.
There's no D. That's it.
There's A, B, and C. That's it. A. A says to draw some gummy worms with different numbers of segments that Crystal and Alexa can share without having to make new cuts. Now, we already said that it's a 2-to-1 ratio, and that they needed to be in multiples of 3 because of that.
Yes. Should we doing this on the back?
Yes. So the first one I'm going to do is a 3-segment. Yes. Where Crystal gets 2 and Alexa gets 1. I'm going to do a 6-segment. And again, for every 2 that Crystal gets, Alexa gets 1. For every 2 that Crystal gets, Alexa gets 1. And I'm going to redraw the 9 one again, because it said sum. Different numbers of segments, draw sum, so 3 is going to be fine. So here's a 9-segment that we just did at the introduction. For every 2 Crystal got, Alexa got 1. And so off to the side, I'm going to write the ratios for those. And again, you should see that those ratios are equivalent. This was a 2-to-1 ratio. 2-4-to-2 ratio. 2-4-6 to 1-2-3 ratio. So all of those should be the same. And front loading you a little bit, tomorrow we're going to talk about tables. And if this was a table and this was Crystal's side and this was Alexa's side, it would have been 2-to-1, 4-to-2, 6-to-3. Do you see a pattern?
1, 2, 3, 2, 4, 6.
1, 2, 3, 4, 2, 4, 6, 8. So I could get the next one, and if I add these together, I know that that's going to be my 12-segment gummy worm. This was my 9-segment gummy worm. This was my 6-segment gummy worm. This was my 3-segment gummy worm. And tomorrow, that's what we're going to be doing. Even though we see those equivalent fractions or those equivalent ratios, it's putting them in a table graphic for you to see, and for you to see that there's also a pattern that runs in there with it as well. So that's just because some of you are already seeing that pattern here, knowing that that's what we're going to be doing tomorrow. We're on B1. Jared is 10 years old. His brother Peter is 15 years old. What are some gummy worms that they can share without having to make new cuts? So I'm doing Peter to Jared because I know that my goal sometimes is to break it down to the unit rate of 1. And that is putting the smaller one second. So it's a 15 to 10 ratio. Now, I know that by dividing this by 10, it's going to get me my unit rate, but can 10 go into 15 evenly? No. So I can't really, without making new cuts, break this one down to the unit rate. But I can break it down by 5. 5 will go into 10 how many times?
2.
2. 5 will go into 15 how many times?
3.
3. So if this is going to be the ratio that I use, what's the multiples have to be?
2 to 1.
3 plus 2 is?
2 to 1.
5. So it's going to have to be multiples of 5. Remember, if she gets 2 to every 1, it's got to be at least 3 segments. If she gets 3 to every 2, it's got to be at least 5 segments. So number 1 says, what are some gummy worms that they can share without having to make new cuts? I already know a 5-segment one is what they can share. With Paul getting 3 to Jared 2, that's their 3 to 2 ratio. And if it has to be multiples of 5, what's my next string?
6.
What's my next gummy worm?
10.
10.
Are we still on B1?
Yes.
Okay.
9 cups makes 10 boxes. So again, for every 3 that Peter gets, Jared gets 2. For every 3 that Peter gets, Jared gets 2. So this is a 1, 2, 3, 4, 5, 6. 2, 1, 2, 3, 4, a 6 to 4 ratio. And again, if I multiply 3 times 2, that's 6. 2 times 2 is 4. So that is still an equivalent ratio. So the next one will be 15. We're not going to do the 15 to 20 to 25 to 30. Again, they're all, if they're multiples of 5, you're going to be able to share them at this ratio. What's the what? 10 boxes. So they have to be multiples of 5, and this was our 5, and this was our 10. What if one M? Then you get a piece of paper and staple it to it when you finish. Now we're on B2. For each worm you described in part 1, write a ratio comparing the number of segments that Jared gets to the number of segments that Peter gets. Now guys, this is Jared to Peter, and order matters. If they ask for Jared first, you have to put Jared first. So this is a 2 to 3 ratio, the first one was, and this one's a 4 to 6 ratio. Yes. 9 boxes. 10 boxes. 9 cups, 10 boxes. What are you guys doing?
Paper.
What kind of paper?
Notebook paper.
It's in the black thing on top of the filing cabinet, first drawer. Number 3. Are the ratios that you wrote for number 2 Are they equivalent to each other? Is 2 to 3 and 4 to 6 equivalent to each other? Yes, 3 times 2 is 6, 2 times 2 is 4. If I multiply it up and across, 3 times 4 is 12, 6 times 2 is 12. It's going to give us the same thing, and those are two of the things that you can check to make sure that they are equivalent. So, for number 4, if I'm at a 2 with up here, Jared, a 3 to 2 ratio, and I want to write the unit rate. Remember, the unit rate is to get the second number to 1. So 2 divided by 2 is 1. What is 3 divided by 2?
1.9.
1.5. Now, because we knew it was a half, we knew we had to make a new mark. That's why with this one we couldn't come all the way down to 1. All the way down to the unit rate, because I would have had to have cut a segment in half, and it didn't want us to make new marks. So that's how I knew I could only come down to every 2 on the first one. Give you just a couple seconds before I erase it. Yes. Yeah, just a minute whenever I can get some room on the board. And put that down. We're starting C. C1. Caleb and Isaiah are brothers. They share a 14-segment shoe. How old could they be? Count Caleb's part of the gummy worm and Isaiah's part of the gummy worm. How many segments are orange?
8.
8. How many segments are purple?
6.
So Caleb could be 8 years old and Isaiah could be 6 years old. If you're just counting the segments and going by the segments. But if I reduce this by 2, 8 divided by 2 is?
4.
6 divided by 2 is?
3.
So Caleb could be 4 and just got 2 sets of 4. And Isaiah could be 3 and just got 2 sets of 3. So these could be their ages. Caleb could be 8 or 4. And Isaiah could be 3 or 6. Everybody okay with that? C1. Number 2. Caleb gets 8 out of the 14 segments of the gummy worm. So he gets 8/14. And Isaiah gets 6/14 of the gummy worm. Now guys, if I had Caleb's part over the whole and Isaiah's part over the whole, and we add it together, it should give us the whole gummy worm. 14/14 is 1, the whole thing. 1 whole thing. Yes. So, when it gives you that information to start number 2 with, then it asks you for A. It tells you to go back up in A, where we did Crystal and Alexa, and it wanted you to write the fractions for Crystal and Alexa. Now, remember to start off with, Crystal was 12 and Alexa was 6. And they were sharing a what segment? Gummy worm at that time. 12 plus 6?
18.
An 18 segment. So, Crystal would have gotten 12 of the 18. Alexa would have gotten 6 of the 18. When you added those together, it would have been your 18/18ths, which would have given you the whole gummy worm. Does that make sense?
Yes, ma'am.
Can you write that?
The answer? Oh.
Jacob.
You like, do you read that? To B. To B wants you to go back to question B. Now we're back at Jared and Peter. What are the fractions of their gummy worm that they would each get at the birthday party? Now again, it's stressing it wants the fraction form now. When we were talking about the 10 and the 15 and it reduced down to the 3 to 2, remember this was Peter and this was Jared. For every 3 Peter got, Jared got 2. So Peter would have gotten 3 out of this 5 segment. Jared would have gotten 2 out of this 5 segment, and the 3 plus 2 would have been your 5/5. Well, not out of the segment, out of the whole worm. He would have gotten 3/5 of the whole thing, and Jared would have gotten 2/5 of the whole thing.
Oh, so it's like, whatever it is, you put it like the full amount.
The whole, part to whole relationship. The full amount is your whole, your denominator. Yes.
I have a question. What are we doing after this?
You're working in already?
Oh, mama.
Oh,
Okay.
Oh,
We got to lesson? No. We're on 2C. C2C. Yes. How does the ratio of segments that Caleb and Isaiah get relate to the fraction of the gummy worms that each get? So the ratio of Caleb, remember it could have been reduced down to a 4 to 3 ratio, which means this would have been a 7 segment, multiples of 7. So that would have been 4/7, and this one would have been 3/7. In their ratio, you got the part to part. In the fraction, you got the part to whole.
Okay.
Is that it? That's it.
Oh.
Again, in the ratio, it was a part-to-part ratio, his part to his part. But when we were looking at the fraction, it was his part to the whole and his part to the whole.
Is that it? That is it. Do we keep it?
Yes. So when we added both of these together, that would have given us 7/7, which would have been the entire gummy worm.
Do we keep this or not?
Now, Friday we did 2.1 equal shares. Today we did 2.2 unequal shares. Tomorrow we're doing 2.3. It is making comparisons with rate tables, and I showed you that vertical table to kind of give you an idea of what that was. So tomorrow when we do the rate tables, we're finished with lesson 2. And it took us 3 days. You're going to take all 3 papers tomorrow, staple them together, and turn them in for a classwork grade.
Yes, ma'am.
Now, especially since I've been doing the problems with you and walking you through them,
And
if
those
you
are all
don't
good.
have parts of them, you will definitely lose points for not having them.
Oh, yes.
Are there any questions before we finish? Yes. That's fine, then you won't turn that part in, you'll just turn your paper in.
Can I go to the restroom?
Yes, quickly. You do not turn your paper in today. I just told you you are turning 3 days worth in tomorrow.
Can I go to the